Hi everyone, welcome to Science with Hawala. And in this video, we're going to uncover the secrets behind solids, liquids, and gases, which are the three fundamental states of matter that shape the world around us. Why is it important to learn about the states of matter and their properties? Well, learning about the states of matter and their properties provides insight into how matter behaves under various conditions. So let's begin. Let's begin by defining matter. What is matter? Matter is anything that has mass and occupies space. Occupying space refers to the volume an object has, and mass represents the amount of substance an object has. So, matter could be anything. It could be a pen, a book, a rubber, sand, and so on and so forth. So, all these qualify to be called matter because they have mass and occupy space. Now, what makes up all these things that we've listed here? What are the basic units of matter? Matter is made up of three main basic units, which are atoms, ions, and molecules. And then matter can again exist in different forms. What are the three forms or states that matter can exist in? First one, solids. Second, liquids. And the last one, gases. These are the three main ways in which matter can exist in. Let's look at some examples of solids. One, we've got a stone. We'll talk about a copper block. Three, we can even mention a pen. So these are three ways in which matter can exist in the form of solids. What about liquids? Liquids, we have water, uh, petrol. We mentioned petrol. We can also mention paraffin. So these are three ways in which matter can exist in a liquid form. What about gaseous state? We've got oxygen, nitrogen. We've also got, we can mention hydrogen. So these are three ways in which matter can exist in a gaseous state. Now that we've looked at the three states of matter, as some of the examples of the three states of matter, let's look at the characteristic properties of the states of matter. So, characteristic properties of states of matter refers to the distinctive features that separates the three states of matter from each other. When we say distinctive features, we're looking at unique features that will help you identify to say this is a solid, this is a liquid, and this is a gas. So let's begin. Let's look at the shape of solids, liquids, and gases. For solids, they have a fixed shape. Liquids, they don't have a fixed shape. Gases, they have no fixed shape either. So, what does it mean when we say a solid has a fixed shape? Simply means that if we have a solid in one container, let's imagine this is a beaker, we have a solid here, a glass block, and we place it on the table, you find that the shape will not change. The, the, the glass block will not change its shape based on the container in which it's placed in or the object on which it's placed on. No, it will still maintain its shape unless you break it into smaller fragments. And even if you break it into smaller fragments, you will find that the pattern or the arrangement of particles will be in a consistent pattern. So that's what we mean when we say solids have a fixed shape. The shape will not be based on in which container it's placed in. No, it will still maintain its shape unless you break it into smaller fragments. Liquids don't have a fixed shape, but they take up the shape of the container. So you'll find that the particles in the liquid, uh, they can vibrate over short distances. So they can rearrange themselves and take up the shape of the container. Gases, gases don't have a fixed shape. The particles are really far away from each other or much further apart from each other. So they will fill up the available space in that container or in that room. Volume, solids have a fixed volume, liquids no fixed volume, gases, sorry, solids have a fixed volume, liquids have a fixed volume, gases don't have a fixed volume. So volume, if you remember, we said that it's the space surrounding that object or the space around that object. So why is that solids and liquids have a fixed volume? It's because the particles are closely packed. The particles are closely packed. For gases, the particles are much further apart from each other. So you'll find that with gases, they don't have a fixed volume. You can bring those particles closer together if you just apply the right amount of pressure. For solids and liquids, they have a fixed volume. It's because they're closely packed. So even if you try to squeeze them together, you might bring those particles just a bit closer, but the difference in that is negligible. So solids have a fixed volume, liquids have a fixed volume. Compressibility. Solids cannot be compressed, whereas liquids as well cannot be compressed. Gases can be compressed. Why is that solids and liquids cannot be compressed? The reason is simple. The particles are closely packed as well. So you can't compress solids and liquids. Even if you do that, you manage, the compression will be so small such that it will just become negligible. For gases, you can compress them because the particles are really further apart from each other, so you can really bring those particles closer together. Arrangement of particles. Solids, the particles are arranged in a regular pattern. So they're closely packed and arranged in a regular pattern. So this is a diagrammatic representation of what we're talking about. The particles are arranged closely in a regular pattern. So that's for solids. Liquids, they are also arranged, they're closely packed, but slightly further apart compared to solids. So that's for liquids. And for gases, much further apart from each other. Then how is the movement of particles? In solids, they vibrate at fixed positions. So because they are really closely packed, the best movement they can ever do is vibrating at their fixed positions. For liquids, they can vibrate over short distances. And for gases, particles move at random at very high speeds. So movement of particles actually affects various properties of matter. An example is density. If the particles are moving slowly, they will come closer together and that object will have a high density. So we have learned about the states of matter and we have looked at the characteristic properties of the states of matter. So thank you very much for joining me on this education adventure. Don't forget to like, share, and subscribe for more engaging content. Until next time, keep exploring, keep learning, and keep questioning. Stay curious.